Alright, so picking up where we left off yesterday in section 4.3. We're now going to do finding values of theta in degrees and radians. We're going to assume all angles are in quadrant 1. Alright, so this again kind of requires that you know your unit circle. And so hopefully at this point we are like starting to memorize where things are on the unit circle, and you can kind of like at least like picture the unit circle and figure it out. If you need a unit circle to look at, that's fine, but I'm not going to be referring to one, I'm just going to be explaining. Alright, so if I want cosine of an angle to be root 2 over 2. Alright, so you might have to remember quadrant 1 of your unit circle. So remember that your values for your ordered pairs are root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and then root 1/2, root 3 over 2. So if we're just in quadrant 1 of the unit circle, we have these three ordered pairs, right? So we have, I guess we'll just draw it real fast, but from memory you should be able to draw this on the side of your paper. You should be able to say that this is root 3 over 2, 1/2. This is root 2 over 2, root 2 over 2. And then up here we're at 1/2, root 3 over 2. You know that this is 1, 0, this is 0, 1. You know that you're at 30 degrees, 45 degrees, 60 degrees. You know that this is pi over 6, this is pi over 4, this is pi over 3. Okay, so this is asking you when is x root 2 over 2, because I said cosine of the angle is root 2 over 2. Remember, cosine is x, so when is the x coordinate root 2 over 2? Well, that happens at 45 degrees or pi over 4. Alright, they want to know when is tangent 1. Well, tangent is y over x, so for tangent to be 1, they're asking when is x equal to y. Well, that's also at 45 degrees or pi over 4, because root 2 over 2, root 2 over 2 is the only time they're the same in quadrant 1. It happens again in quadrant 3. Alright, so sine of theta is 1/2. That's saying when is the y coordinate 1/2. So in quadrant 1, the y coordinate is 1/2 at 30 degrees or pi over 6. Alright, so cotangent. These are a little, if you gotta think a little bit harder. So if cotangent is root 3 over 3, if we did the reciprocal of that, that is 1 over root 3. So they're saying then is tangent 1 over root 3. So then you got to stop and think. For me to get 1 over root 3, that would have had to been 1/2 over root 3 over 2. This is not a true statement. Back it. Let's just start over. Sorry. Root 3 over 3. Before I rationalized was 1 over root 3. Sorry, that's not the reciprocal. Before I rationalized root 3 over 3, it was 1 over root 3. For it to be 1 over root 3, then it was 1/2 over root 3 over 2. Cotangent is x over y, because it's the reciprocal of tangent, which is y over x. So the ordered pair we're looking for is 1/2 root 3 over 2, which happens at 60 degrees or pi over 3. This one up here. Alright, if secant of theta is root 2, that means that cosine was 1 over root 2, which is root 2 over 2 if you rationalize it. So cosine is root 2 over 2. We're back to answering number 5. So 45 degrees pi over 4. Alright, next we have, can we fill in the missing values from this little table? So it's really just, I'm telling you cosine of 45 degrees. So 45 degrees is the same thing as pi over 4. And the value is root 2 over 2, because the x coordinate at 45 degrees is root 2 over 2. Alright, so tangent, they gave you pi over 3. You know pi over 3 is the same thing as 60. So tangent is y over x. So at 60 degrees, this is the ordered pair. They want y over x. So root 3 over 2 divided by 1/2, which is just root 3. Alright, Here they say sine is 1/2. So they're asking when y is 1/2. So y is 1/2 at 30 down low. So 30 degrees, which is pi over 6. They want to know when cosecant is root 2. So they want to know when the y coordinate is root 2 over 2, because cosecant is the reciprocal of sine. And that happens at 45 degrees, or pi over 4. And then here they give you an angle, so you know that pi over 4 radians is the same thing as 45 degrees. And then sine at 45 degrees is root 2 over 2. Alright, so starting probably tomorrow, maybe Friday, we're going to, I may wait and do them next week, but sometime in the near future you're going to get little quizzes like every couple of days where you're just answering questions like this. If I say sine of 30 degrees, you got to be able to give me an answer without your unit circle. So make sure you're studying that unit circle. Alright, so moving on. So can we solve a triangle for a specific thing, or can we solve an entire triangle? Depends on what they ask us to do. So if they give me information, can I draw a triangle and figure out something else? Okay, so they told me that side A is 5 and angle B is 49 degrees. They want me to find side B. All right, so if I draw a triangle, a right triangle, because that's all we know how to handle right now, and they gave us one to go off of. They didn't even make us have to like figure it out. Okay, so if I take this triangle, it was given to me, and I fill in what I know. So I know B is 49 degrees. I know the adjacent side is 5. I'm going to find the opposite side. All right, well, if I know adjacent and I'm looking for opposite, that means I'm using tangent, because tangent is opposite over adjacent. So tangent of 49 degrees would be B over 5, because that's the opposite side over the adjacent side. And then how do I solve this for B? Well, I multiply by 5 on both sides. And I just type that in my calculator. That's in degrees. So remember, your calculator has more than one mode. So the first thing you do is go make sure that your calculator is in degrees. And then I can do 5 tangent 49, and I get my answer. I know that side B is about 5.8, and I rounded to the tenths because they told me to. All right, next we're going to take angle A is 16. Side B is 14. And they want us to find side C, which is the hypotenuse of my triangle. So again, we're working off of, this is the triangle that was given to me. Now we're just labeling it. All right, so this is the adjacent side. They want the hypotenuse. So adjacent and hypotenuse is cosine. So I write an equation with cosine. Cosine of 16 degrees is 14 over 7, because that's the adjacent and the hypotenuse. All right, so I've got to multiply by C on both sides, and then divide by the cosine. You can legally just switch these, but there's 2 steps of math that's actually happening. I don't care if you show those. You can just switch them. It's okay. So ultimately, in my calculator, I'm going to be typing in 14 divided by cosine of 16 degrees, and I get 14.6. All right. 17 is another one. So label your triangle. Angle B is 64. Side B is 19.2. Find C. All right, so this time they gave us the opposite. They're asking for the hypotenuse. So I use sine. Sine of 64, opposite over hypotenuse. Remember, I'm looking for C, so it's illegal to just switch these. I multiplied by C, I divided by sine of 64 degrees. Type this in your calculator, you get 21.4. All right, so before we can do some word problems, we have to make sure we understand some vocab. So angle of elevation versus angle of depression. Angle of elevation is when I'm like on the ground looking up at something, and it's the angle that I'm looking up. Angle of depression is like I'm in the air and I'm looking down at something. But notice that when you do angles of depression, that your angle of depression is here, but it winds up being the same as this one, because if you think of the ground and your line of sight as parallel lines, they're being cut by a transversal. So this angle is the same as that angle. Keep that in mind when you're drawing pictures for some examples. Okay, so word problem example 1. We have the chairlift at a ski resort rises at an angle of 20.75 degrees and attains a vertical height of 1,200 feet. How far does the chairlift travel up the side of the mountain? All right, so we are assuming that if we do the straight up of the mountain, the height with the ground, that makes a right angle. We are on a chairlift going up the mountain. That angle that it rises is what they gave us, the 20.75. We know that the straight up vertical, that's the keyword, height is 1,200 feet. And they're asking us how far it actually travels. So that chairlift goes up the mountain at an angle. So this is how long the cable would need to be. So that's what we're looking for. So from this angle, we know the opposite. We're looking for the hypotenuse. So we use sine to set up our equation. To solve, we're going to switch these guys and divide. And you get 3,387 feet. It rounds to 0.0. All right, example 2. An airplane is approaching an airport with a 6-degree angle of depression. At the time, the aircraft's distance measuring equipment shows it is a slant range distance of 6.5 miles from the end of the runway. How far above the runway is the airplane? To the nearest hundredth of a mile. All right, so you have an airplane in the air. It has a line of sight here. They told you that its angle of depression is 6 degrees, so it's flying down to make a landing. Okay, it's flying at an angle of 6 degrees. Well, if this is 6 degrees, then the angle from the ground looking up at it is also 6 degrees. It tells you the slant range distance, so how far does it really need to travel? But it's asking how high is it off of the ground. And again, the ground and a vertical distance are going to make a right angle. All right, so if this is 6 degrees, this is 6 degrees. Okay? Or you can think of, if I'm looking for this, it's the same as that. It's whichever way you want to think of it. Either way, from your angle, you know the hypotenuse and you're looking for the opposite. So you set up your equation. And then we can multiply by 6.5. Type this in our calculator. You get 0.68 miles. This one told you to round to the nearest hundredth. So make sure that you're paying attention to your directions. All right, example 3 is a bit of a doozy. All right, from the top of the mountain, 3,000 feet above sea level, the angles of depression to 2 ships in the water measure 18 degrees and 13 degrees respectively. To the nearest 10 feet, find the distance between the ships. All right, so you are standing on top of a mountain. Here's your line of sight, which is parallel to the ground. If you look down 13 degrees, you can see a ship. If you look down 18 degrees, you can see a different ship. All right, the goal is to figure out how far apart are these 2 ships. All right, so again, if this angle is 13, then this angle is 13 because of parallel lines cut by transversal. This angle is 18, then this angle is 18. All right, so if we use a ship A and we figure out how far away he is, and then we figure out how far away ship B is, we can subtract to figure out how far they are from each other. All right, so we know that this is 3,000, and that's the opposite, and we're looking for the adjacent, like this side right here. So for ship A, we're going to say tangent of 18 is equal to 3,000 over A. So then these guys switch places, and we just divide. Okay. I'm not going to round to the nearest 10 feet until the end. So here I just rounded to the nearest 10th. All right, so then for ship B, he has an angle of 13 degrees. Opposite of 3,000, adjacent of, we'll call it B. All right, so again, multiply by B, divide by tangent. These guys just switch. So you've got 3,000 divided by tangent of 13 degrees, which should give you this. All right, so the distance between, you're going to subtract those numbers, and you get this, but then they asked you to the nearest 10 feet. So you got to round that to the tens, not the tenths, but the tens place. All right, so that is section 4.3. Again, like always, please let me know if you have questions. I'll be happy to answer them.